Good afternoon to one and all present here. Our today's keynote speaker of the session, Dr. K.C. Bora sir, Emeritus Professor, College of Engineering, Pune. Dr. Jyoti Desmukh, Group Director, Sagar Group of Institutions. Dr. Manish Billore, Principal, Sistek Ratibad. Professor Kshitij Both, Head of the Department, Mechanical Engineering, Sistek Ratibad. And convener of this National Symposium, Dr. Alkavani Agrawal ma'am, Professor and Head Department of Automobile Engineering, UIT RGPV, and Dr. Abhishek Chaubey sir, Associate Professor, Department of Mechanical Engineering, Sister Kratibad. Faculty members and dear students, I, Dheeraj Kumar Singh, Assistant Professor from Department of Mechanical Engineering, welcome you all in this 3 days National Symposium on Recent Technological Advancements in Electric Vehicles, jointly organized by Department of Automobile Engineering, UIT RGPV Bhopal, and Department of Mechanical Engineering, Sistek Ratibad Bhopal. Objective of this National Symposium intends to bring together academicians and industry experts from different parts of the country to exchange knowledge and thoughts, focused on latest research and work in the field of electric vehicle technology. Now, I would like to request our principal sir, Dr. Manish Billore, to welcome our today's expert of the session, Dr. K.C. Bora sir. Respected principal sir.
Thank you, Dheeraj sir, and a warm good afternoon to honorable expert speaker for today, Dr. K.C. Vora. Warm welcome to the conveners of this National Symposium on Recent Technological Advancements in EV, that is Professor and Head, Automobile Department, UIT RGPV, Dr. Alka Bani Agrawal, Associate Professor at Mechanical Engineering Department, Sister Chaubey. All the those who are part of this event right since the morning, and the faculty members of UIT RGPV as well as SISTEC, and the students of both of the institutes. Good afternoon and warm welcome to all of you to the second session of this symposium of day one. It's indeed a pleasure to work with the most prestigious organizations in Madhya Pradesh, UIT RGPV. Thankful to Dr. Alka Bani Agrawal ma'am to allow us that we could work with her and the entire team of UIT RGPV. Plus a galaxy of speakers. It's indeed our fortune to have so many speakers. Right from the morning, we were fortunate to listen to Mr. Pankaj Sonalkar, who is head of EV at Mahindra and Mahindra. Also, there is a long list of speakers in next 3 days, whom we are going to listen. So, when it comes to mobility in India, there is only one name that strikes all of us, is that SAE. And I won't hesitate to share my views and share my past experience when I was a lecturer way back in 2001. When it came to SAE, the one and only name that came to all of us was Dr. K.C. Vora. Again, thanks to you to introduce SAE in Madhya Pradesh. I remember your encouragement. I remember the encouragement of Professor Subir Kumar Saha from IIT Delhi, because of whom we could start the first chapter, SAE chapter of SAE. Those days it was not SAE, it was not SER, it was actually SAE. So the first chapter of SAE in Madhya Pradesh and Chhattisgarh in 2001. Thanks to you, sir. Whenever I meet you, I remember those days, and you do not get irritated with all of the messages that I keep going to keep giving you. The intention is to have such eminent people on board, so that whenever things progress, whenever the situation change, I always give this example to my students, like the change in Yug. So there was Kali Yuga, then there was Satyug, then Treta Yuga and Dwapar Yuga and all that. But now in automotive industry, the Yuga has been changing from IC engine Yuga to the electric vehicle Yuga. And people of such eminence, people of such seniority like our Bora sir, will definitely be instrumental in letting us know that how to adopt yourself to the change of Yuga, how to react to the situation, and to how and find yourself a best fit in that change. In the morning session, as Mr. Sonarkar has also mentioned, that it would be the survival of the fittest. So, regardless of the experience, regardless of the age, regardless of the branch of engineering, if a student adapts himself or herself to this change smoothly, then he or she would be the best fit in the industry. So, moving on the same lines, I'm sure this symposium will progress, and there will be a synergy between all the speakers, all the contributors, all the people who will be part of the discussion, so that by the end of the day three, we can come to a conclusion, a positive conclusion. And again, I would quote speaker for today morning, Honorable Vice Chancellor, Professor Sunil Kumar sir, that he has already proposed a joint work between the institute, rather the two institutes, the Sister Ratibad and UIT RGPV. He has appealed to both of the institutes to get in touch with industry as much as possible and work in collaboration with them, work in association with them, work under their guidance, so that we can definitely come up with some kind of a tangible solution to the existing problems, be it in battery, be it in mobility, be it in charging, and so on. So with this, I once again welcome Honorable Dr. K.C. Vora to this 3 days symposium jointly organized by UIT RGPV and System World. Thank you, sir.
Thank you, sir.
Thank you
Thank
so
you
much,
very much.
sir. Thank you so much, sir, for your valuable words. Before inviting today's keynote speaker of the session, let me give you a brief introduction of him. Dr. K.C. Bora has done his bachelor's in mechanical engineering from BVM Vallabh Vidyanagar, master's in automobile engineering from VJTI Mumbai University, and his PhD from IIT Bombay. He has a vast industrial and academic experience of 36 years and has been associated with Walchand Nagar Industries, Emitech Emission Controls, Mahindra and Mahindra, and ARAI. He has specialized in design, development, and testing of powertrain and vehicles, safe, smart, and sustainable mobility, electric vehicles, innovation and research, skill development, learning and development, knowledge management, business strategy, digital marketing, and communication. He is skilled in the area of electric mobility and chairs ASDC expert group of electric vehicles. He has conducted extensive study of automotive industry standards and used them in development of qualification pack for 10 job profiles in the area of electric vehicles for ASDC. Recently, he has superannuated from ARAI as head of ARAI Academy and joined College of Engineering Pune as emeritus professor. He is also nominated as AICTE INAE Distinguished Visiting Faculty in India. He is instrumental in starting ARAI Academy, which conducts training programs and graduate, postgraduate, and doctoral courses in automotive engineering, electric mobility, and electric and autonomous vehicles in collaboration with various universities. He was also the coordinator of electric vehicle awareness program mooted by Ministry of Heavy Industries and road safety awareness program mooted by Ministry of Road Transport and Highways. He has gained a course cross cultural exposure by working with industries and universities from India, Germany, UK, USA, and Sri Lanka. He is also the advisor in various activities of SAE India, under which he conducts series of his students' activities like AWIM and Baja SAE India. He started eBaja as EV initiative from 2015 with blessings of Dr. APJ Abdul Kalam. He is chair Baja SAE India organizing committee and also SAE India faculty development committee. He has 111 technical papers, 4 books, and 3 patents to his credit. Now, I would like to invite and request Dr. K.C. Bora sir to share his words of knowledge on the topic automotive standards and research avenues in electric vehicles. Respected sir.
Thank you, Professor Dheeraj Singh, for a nice introduction, and thank you, Dr. Abhishek Chobe, to invite me here, and Dr. Manish Vilore. I know you from almost last 15 years. I can see your progress, And also, I can see all those trophies behind you. You have been doing great. And thank you, madam, Alka madam. And I am all set to give my presentation. So I would share my PPT, share screen, and just let me know, are you able to see my presentation? Can you confirm, are you able to see my
Yes,
presentation?
yes, sir. Yes, sir. It is visible, sir.
Okay, thank you. Thank you very much. So I have a presentation for around 90 minutes and around 130 slides. And today I'm going to speak on electric vehicles, standards, and research avenues. So the presentation is divided in two parts for electric vehicle. One, I'll talk about what are the standards which are used to test and certify electric vehicles and their components, and what are the various research avenues which students, professors in India can work on. So basically, we in India, because of so much change in the mobility scenario, we are talking about ACES. When I say ACES, it is autonomous, connected, electric, and shared mobility. And this ACES is an acronym which has become widely used worldwide. That these are the technology in which everyone must start working. Yes, I am also a strong supporter of engines, and I know that it's not going to be easy for the engines to go. There are many areas where engines would be still used, but the contribution towards engine would reduce eventually, and we will have more and more electric vehicles worldwide. Today in India, the penetration of electric vehicle is less than 1%, and but we are all very sure that by 2030 it would be 30%. However, in the Indian context, ACES has been slightly changed. Instead of autonomous, we call it as affordable and assisted. Instead of connected, we call it as connected and shared. Instead of electric, we call it eco-friendly. It is not only electric vehicle, but alternate fuels like ethanol, methanol, biodiesel are all included. CNG, LPG are also included in it. And shared mobility is here till the last mile connectivity. And but for us, more than shared, it is safe mobility which is important. Safety is one of the important criteria. So, of all four ACCs, that is affordable and assisted, connected and shared, eco-friendly and safe, eco-friendly is what we will narrow down, and under eco-friendly, we will talk about electric vehicle and how do we test them, how do we validate them, and how do we certify such electric vehicles. So, if you look at the overall prevailing conditions, the crude petroleum prices have been rising, and today, wherever you go, gasoline is more than 100 rupees per liter. Similarly, more and more people are shifting to cities, and it is said by 2050, more than 50 population of the Indian would be in cities, and hence our government is developing more and more smart cities so that more and more people shift to those areas and can have their livelihood. Uh, Also, whenever we make cars, there are side effects. We increase pollution, noise pollution, air pollution, and this will all lead to global warming. And so we need to take care of our environment, and we need to be aware of the climate change which is going to happen or is happening. And hence, every Indian government is committed towards Kyoto Protocol, and various policies are established like emission standards, like CO2 emission norms, and international policies. So we are aligning ourselves to international policies, which we call it as harmonization or globalization of norms. Moreover, besides CO2 emission reduction, emission standards have been regulated, and uh, also, the support to electric mobility is given through FAME 1, FAME 2. So, right now we are under FAME 2. Okay, fine. So, you all understand that the contribution of CO2 is the highest from the transport sector, and hence we need to work on zero emission vehicle. Somewhere in 1970, we talked about catalytic converter, and then later on in 85, we talked about diesel after treatment device like is DPF, diesel particulate filter, and now we are talking about electric vehicle. You all must know that India produces around 25 million vehicle in a year, out of which 80% of the vehicle are two-wheeler and the rest are three and four-wheeler like passenger vehicle, three-wheeler, commercial vehicle and so on. So on an average, we produce 21 million two-wheelers and around 3 to 4 million four-wheelers every year. So now the changing phase of the mobility is said to be the electric vehicle, and electric vehicles are here to stay. India has developed in last 2 3 years, couple of years, very drastically in the area of electric mobility. So if I want to define different types of vehicles, we have e-cycle, we have two-wheeler, three-wheeler, e-rickshaws, and e-buses. So all these vehicles are any vehicle, electric vehicle which runs on Indian road uh, need to be certified. And how are this certification done? How are the notification given? Is what I'm going to talk today. So you can see there are advanced electric vehicles in India, and also the Indian scenario, international scenario talks about the the electric vehicles. Okay. So in Japan, we have a lot of electric vehicles in public places which are open to public. And similarly, in China, we have EV stations uh, where electric vehicles are charged. So there are different categories of electric vehicle, off-road vehicle, within the campus, hospital, airport, university, resorts. Now all these vehicles which are moving within the four walls of a complex need not be certified. It must be safe for the internal use, but it need not be certified. It can be certified only if the vehicle is going to run on the roads. So any vehicle which is less than 250 watts need not be certified. Uh, so when all the vehicles which are more than 250 watts needs to be certified. So whether it is an e-rickshaw or an e-auto or a four-wheel passenger vehicle or a heavy vehicle, there are different categories on which we need to work. Similarly, we have other categories of vehicle and we divide them into L1, L2, L3, L4, and L5. So these regulations have become predominant in India in the last few years. In earlier days, the CMVR technical committee brought in the BOVs under preview of CM defining the type approval procedure of BOVs in November 1999, comprising of members from AI, VRD, ECMAS, etc. And then the automotive industry standards were formed in September 2003, and the mandatory requirement from April 2005 to so this were also introduced. So you would see that gradually the electric vehicles were here to stay, even though we started working before 22 years, and Dreva Electric produced that first electric four-wheeler. Since then, we have many manufacturers of electric vehicle. Two-wheeler industry itself has more than 25 variants. So the mandatory requirement from April 2005 was also declared. So with this background, let us see what are the standards and regulation of electric vehicle under central motor vehicle rule. Okay, so just give me a minute. Just give me a minute. Yeah, so sorry for the disturbance. We will now go ahead and talk about various standards which are prescribed for testing and certifying electric vehicles. So there are many agencies in India who are certified. Like we have ARAI in Pune, we have ICAT in standards for pure electric vehicle, we have separate standard for hybrid electric vehicles, and we have separate standards for charging stations. India is the only one first country who has approved retrofitment of electric vehicles on the old cars. You would be surprised to know that there are 250 million vehicles running on Indian road. Hello, am I audible?
Yes, sir. Yes, sir.
Yeah, yeah, fine. I will request everyone to keep their mic in mute. So you would be surprised to know that India is the first country which has approved retrofitment of electric kit on IC engine vehicles. So there are 250 million vehicles running on Indian roads with IC engine, and in case some of them may be very old with BS1, BS2 emission compliant, and now we are talking about BS6. So the engine can be removed and the e-kit can be installed, and the vehicle can run as an electric vehicle. So we will be talking about all these standards, whether it is for electric vehicle, hybrid electric vehicle, or charging station, or retrofitment. So under CMVR, Central Motor Vehicle Rules Homologation, you can see there are separate standards for electric vehicle, separate standard for battery, separate standard for chargers, separate standard for hybrid vehicle and retrofitment. And there are so many miscellaneous other standards which are related to electric mobility. So these are totally 6 set of standards which are uh, here you can see that, and they're all released through statutory rules and order or general statutory rules by the government through the ministry. So if there is any vehicle which is less than 250 watts or 0.25 kilowatt, an electric vehicle, then we don't require any certification. This electric vehicle is like a cycle, and it can move at the speed which is less than 25 kilometer per hour, and the power which is less than 250 watts. So there are some bare minimum checks are required, and this can be done. Okay. So when we talk about standards and regulation, there are different notification through which they are released. So here you can see AIS 038 is for construction and functional safety. AIS 039 is for measurement of electric energy consumption. AIS 040 is method of measuring the range in distance traveled. And then 041 measurement of net power and maximum 30-minute power. And CMBR type approval for EV, the entire booklet on AIS 049. And AIS 048 and 156 are standards related to batteries. So AIS 048 is an old standard, and now it is being converted to AIS 156 and is under implementation. So we have derived all these standards from the European standards. Okay, fine. Also, we have standards for hybrid electric vehicles. So AIS 102 Part 1 and AIS 102 Part 2 are some of the important aspects which where we check and certify hybrid electric vehicle. So these are some of the standard. For example, AIS 123 talks about retrofitment kit. And then we must also talk about AIS 138, AC conductive charging and DC conductive charging. Then there are different types of charging couplers, and depending on the standards, those need to be refined. ARI also strongly believes in electric vehicle safety, and through various notifications, whether it is related to EMI, whether it is related to crash frontal impact, or whether it is water bidding test, everything is taken care of. Yes. Are there any questions?
Sir, your camera is being can you reset camera?
Are there any questions up till now, or shall I go ahead?
Sir,
Is there any class now?
may I audible, sir?
They can continue. Yes, yes.
Yes, sir. Can automobile industry easily shifting their emission norm from BS6 to other coming norms?
Just 1 minute. 1 second. My internet is. Give me 1 second. Are you able to hear me?
Yes, sir.
Hello?
Yes, sir. Yes, sir.
Can you repeat your question?
Yes, sir. Sir, can automobile industry easily shifting their emission norms from BS6 to any other coming norms, sir?
Oh, no, no. I'm able to hear you. You said automotive industry is shifting from engine to electric vehicle. Am I correct?
No, sir. No, sir. No, sir. Sir, automobile industries can easily shift it to the BS6 to any other coming norms in the future.
Yeah, yeah. So, for example, it could be BSL norm. So, the industry is ready. I must tell you that automotive industry is ready in all respect. Any company also will work on future norms. So, the research and development wing of any organization has to keep an eye on the future norms, and whether it's a norm which is derived from Europe or whether it's a norm which is derived from California, every company has to be ready itself. Most of the time, it is combustion optimization and addition of opportunities which makes the job, but still it is ready. So any company makes any product, not only compliances with the regulation, it also ensures that in future, if the regulation be thicker, to meet that, no plant, any plant will be upset. I hope that answers your question.
Yes, sir.
Sir, your audio is poor. Voice is not
Yeah,
clear.
yeah. What is so the fluctuation? If you want, I can come out again, join. Is that fine? I will do one thing. I will come out the system and again join. Okay.
Okay, okay.
Pankaj, is voice clear now?
Yes, sir. It's clear now.
Hello?
Yes, sir, your voice is audible now.
anyone tell me whether am I audible?
Sir, no, it's okay, sir. You can may continue.
Fine. So let's share the screen once again. I am okay. So safety is one of the very important area, whether it is safe when vehicle is on the flooded road, or whether there is a crash, or whether there is electromagnetic interference. All this circle of needs to be checked before certified. Safety based precautions need to be taken at the time of buying as approach. Now, sir, is it audible?
Sir, your voice is clear, sir.
Okay, okay. I don't know what is going wrong, but after some time, it's getting disconnected. So let us hope it will continue. So let me share the slides once again.
Yes, sir.
हो गया निपट गया
Okay, fine, sir. I think I can switch off my video so that the
Yeah,
bandwidth
yes,
will
sir.
be better.
Yes,
Okay.
yes, yes. Okay, sir. Okay, sir. It is visible.
Okay, fine, fine. So we talked about AI 039, 040, and 041. AI 039 talked about electric energy consumption. AI 04 talked about the range of the vehicle. कितना देती है माने एक charge में how much will it run? Will it run for 80 kilometer, 90 kilometer, or 100 kilometer? And AI 041 is about measurement of net power and maximum minute 30-minute power. So, what is the overall power, which may be for a temporary situation, or what is the maximum 30-minute power for throughout the 30 minutes? Whatever is the maximum power is taken as the maximum unit power. So net power is measured on chassis diameter at wheels of the vehicle by replacing battery of vehicle with constant power supply, and then the vehicle is kept for 30 minutes at the 30-minute power declared by manufacturer. So besides testing for the electric kit, one is to test the entire vehicle. For example, we need to check for the vehicle weight, max speed test, brake performance, gradability, pass by noise. All the tests which are done on a normal needs to be done on electric vehicle also. Then what is the vehicle weight? What will be the maximum speed? Performance? What is the gradability? All these are checked. Then we go to traction battery. For testing of battery, the famous standard is called AIS 048, which is being further modified of AIS 156. So you can see typical battery. They are similar to but the battery can have uh, different shape and size, as you can see here on the right. So under the AIS 048, performance and abuse testing for traction is suggested, and so under the series, it could be a mechanical abuse test, it could be a mechanical short test, and so on. We also have to check for the electric abuse test and the mechanical abuse test. Under electric abuse test, we need to check for short circuit test and the overcharge test. In short circuit test, hard short less than 1 second, the conductor of less than equal to 5 milliampere for 10 minutes needs to be looked into. Observation for an additional 2 hour period, and as there should not be any physical damage to the case or other mechanical parts, maintaining instruments, and so if you see this under mechanical abuse, there are two tests. One is called short circuit test, another is overcharge test. Then again, we have overcharge test and so this is about all the tests from sustainability point of view, and then there is also supported by the material. Okay. So then they also need for a shock test. Test is carried out on battery module with 100% level access via the lateral component vertical. Then there are acceptance criteria depending on your requirement. Besides this test, you can also do the rollover. You can do the nail penetration test. These are the tests which are not. Okay, fine. So basically, the acceptance criteria is that the volume of the electrolytes each position shall not be more than 25 million per mole. Okay. So let's go to the next slide. And we have completed 50 slides. We completed around 40%. Okay. So here AI is running a nail penetration test. where batteries modulated with mild steel rod which typically should. The rate of penetration shall be 8 centimeter second nominal. And the orientation of penetration shall be particular to the plates. This last test should be done in an indoor facility. The container is to collect the electricity. This battery should be the remaining one. So one has charging and the test pneumatic tractor. So you can check that what type of test can be done or a nail tractor and what are the exercises. Okay, fine. So now let's talk about retrofitment kit. There are around 10 manufacturers whose retrofitment kit has been approved, and if we do retrofitment, our cost will go down. Also, the overall will go down. So then I talk to you about AIS 1, 2, 3. So this are standards for retrofit degree. So now let us talk about type approval procedure for electric and hybrid vehicle. They are common. Uh, Type approved introduced in market for pilot demonstration project intended to work scale. Is process where the products can be made and can be submitted to the test agency for certification. So here public charging infrastructure is the key element in acceptance of vehicle by users. Okay. So there are various types of chargers and each charging gun are different. So one has to look into the system. So there are many charging stations at public place, for example, Japan, and so on. So we saw electric vehicle, and now we are talking about hybrid electric vehicle. In a hybrid vehicle, we have an engine and electric motor both. In an IC engine vehicle, we have only engine, and in electric vehicle, we have only electric vehicle. So here it's a combination of all. So the combined system improve the whole vehicle efficiency to increase economy and reduce tailpipe emission. So in hybrid, we in series, the engine turns the generator and engine and electric motor run the transmission at the same time. So only the electric motor drives the transmission, and the capable of working simultaneously and independently is the learning output. Okay, so when we say that a particular vehicle is hybrid, it can be micro hybrid, mild hybrid, power and the total plug-in hybrid. So when you say micro hybrid, it is used for temporary purpose, and hence you move ahead and with the power, become more and more powerful ones. Okay. So you can see the classification based on the degree of hybridization of any vehicle. So initially it can be a micro hybrid. That means you just start and stop at the signal, and then we gradually promote ourselves to mild hybrid, full hybrid, and plug-in hybrid. Okay. So these are the EV regulations related to AIS 102, Part 1 and Part 2. This is related to approval for electric. Okay. So hybrid, there are series of hybrid vehicles, series hybrid, parallel hybrid, range extended hybrid, plug-in hybrid, strong hybrid. So we need to work on all these standards and ensure that the standards are available. Then comes AIS 102 type approval of hybrid electric vehicle. And here Part 1 talks about if the weight is more than 350 grams, and part 2 is if the weight is less than 350 grams. So there are various CMVR procedure for approval of retrofitment device. So the first prototype has to be submitted to a testing agency. It will check with respect to the kit component and then do the regulation related vehicle travel test. Okay. So why do we do retrofitment? As I told you, there are 250 million vehicles running on Indian road, and it needs to be, though they also must reduce emission and not just BS6 vehicle or vehicle which are fitted with electric kit. So we need to educate the mass and then ensure that we can do this. So these are some of the pictures of the vehicles converted to electric vehicle in last 5-6 years. You can see the batteries, how they are charged. Okay, so these are how a hybrid electric connected vehicle will look like. Now with this, I complete my part of presentation related to standards and testing and certification of electric vehicle. And now I'm going to, we are halfway through, and I'm now going to talk about how do we do research in this field of electric vehicle. Whether you are an academician or whether you are a professional, there are certain areas which everyone must understand to clear the mind. So for any product development, we use a V-shaped product development cycle where we design and then we implement and then we operate and do validation. So if in India the research is more oriented towards software, but something hard needs to be done. So whether it is electric vehicle architect, BAHA, data and analytical transfer for topic for discussion, uh, then software architecture, smart solutions, energy storage solution, energy management, electric motors are some of the areas which we must consider. So there has to be a test facility for testing electric vehicle, and we need to learn component sizing and specification. Then we need to learn the control system. We need to learn the vehicle calibration and the system calibration. Okay. Then there are various components like motor, battery, charging station, which needs to be looked into. So this is how a typical motor with rotor and stator will look like. So this is a typical classification of an IC engine, and predominantly uh, mechanical and electrical engineering. And you can see various types of motors here. So let's quickly look into the different types of electric vehicle. One is called PM, permanent magnet motor, and third is called switch selectors motor. So there are different types of motors, but in India we have 3 types. And very good contribution in the students and the motor. Advantage of electric vehicle is when you are and variable power, when you have so what is important is that in a road so then also selected better with respect to it is vehicle payload, whether it is vehicle So another the time now. So we are now 2:51. We'll be able to finish by 30. Yeah. Electric motor design for any yeah, and then design or size. We have to ensure that it is finally once the motor is ready, we must is getting disconnected and then yeah. Okay, so let me share once again.
Yes, sir.
Share, share screen, and share. Hide. Okay, sir, visible. So, here
Sir, your screen is not visible to us, sir.
yeah. Visible.
No, sir.
Yeah. So let me Hi, you are able to see me, right? आवाज आ रही है? Okay, fine, fine. Okay, I'll continue. Are you able to see my slides?
Sir,
I'll switch on the
screen
video.
is not visible. Your voice is clear, but screen is not visible to us.
I think that I have done this. So let me uh, delete
It's
part.
visible. It's visible to me.
Fine, fine. Okay. Are you able to see the slides now? Tell me, somebody has to tell me whether the slides are visible or not.
Sir,
Yeah, fine.
it is,
I would continue with electric motors. So we saw that it is very important to design electric or select an electric vehicle or understand the selection criteria, the motor or select of the cell. We need to check it is the corresponding controller for the motor. And all those phases need to be discussed. Also, motor we must and also the cost, performance, and durability aspects of the motor. So the we need to use various software for its design and optimization. I have rejoined. And am I audible and visible?
Now
Yeah.
you are visible and properly audible, sir.
So I changed to hotspot, and I hope that hotspot would work. So let me
Yes,
share
sir.
the screen once again. Share screen. So I was talking about motors, and then the next step is to discuss about power electronics and control design. So software from ANSYS and Altair explain how from basics you can move up towards design and development of powertrain electronics, and to consider its performance and consider its value. Okay. Then we have energy management system, which we, in terms of battery operated vehicle, we call it as BMS, battery management system. And there are many ways by which you can optimize the entire battery management system. Uh, then there is an energy management system which talks about state of charge, state of health, cell balancing, and so on. Okay. So electric vehicle is a very interesting field. The Nobel laureate Dr. John Goodenough, one of the professor, uh, invented lithium-ion battery, and by the time the lithium-ion battery is going to scale up in mass production, Dr. John Goodenough is ready with this next set of battery, which is called a glass battery, which is 3 times better than the lithium-ion battery. Then we talk about the energy storage system and the battery terminology. So whether it is an air convention, liquid cooling, or liquid solid cooling, we need to understand all these options and acronyms. So batteries could be of different type, like lithium ion, lithium metal hydride, nickel metal hydride, metal air, and days of the conventional batteries are almost gone. Okay. So the batteries could be in the cylindrical form, it could be the pouch cell, or it could be the prismatic cell. So these are the different definitions of the battery: battery cell, battery module, battery pack. So these are, you can see, the battery pack can be as big as a building, and it can be as compact as can be fitted in the seat of the two-wheeler. So battery design is another important criteria, and one has to work it on various aspects of battery. So the overall battery pack requirement for XEVs will depend on this, whether it is power capability in kilowatt or it is engine capacity in kilowatt per hour. So for different applications, there would be different graph. Okay. Sir, am I audible?
Yes, sir.
Yeah. Hopefully everything is going well. And please
Yes,
bear
sir.
with me. Only 25 slides are left. So I
Okay,
talked about
okay.
motor. Yeah, I talked about motor. I talked about electronic systems. I talked about controller, and I talked about battery. right? So there are different materials used in the battery. One second. I'm in lecture. Maybe I can. You can call me after 1 hour. You can continue with the meeting. Yeah. So you will see that lithium ion has become very famous, but then there are many other battery material also which should be considered. Okay, and this all these materials required for the battery are resourced from various countries like Australia, Portugal, Russia, Congo, Peru, China, and so on. So in earlier days we were getting this from China, and then later on Japan and uh, other places, Korea. But these days we have signed an MOU with other countries like Bolivia, and our battery materials are coming from there. So lithium ion derivatives in batteries, and one must understand the energy storage solutions. Uh, and then there are many other advanced areas like supercapacitors and HESS is what is required. Okay. Let's quickly look at the charging stations. So there are different types of charging: the slow charging, the fast charging, and slow charging would be like AC 001, or DC. If it is DC, then DC 001. Okay, fine. So charging is one such issue, and the charging time is another issue for which people have a lot of anxiety, and this can be solved by using more of such material. So in terms of standards for the EV charger, these are safe, scalability, saving, security, and simplicity. EV charging also is a good initiative, where multiple initiatives by government of India to promote adoption of electric vehicles were taken, including FAME 1 and FAME 2, and these are the specifications. We also need to work on smart charging solution. There are various charging mechanisms which are filed and which are patented. We need to work on those areas to make charging more easier, faster, and smarter. Then comes the battery swapping system. India is the only country which is allowing battery swapping. That means when the vehicle stops, uh, the battery can be swapped, the new battery can be put in, and the old battery can be removed. And then again, next time, the old one get repaired and can join back into the system. Okay. So we need to work on areas where intelligent solutions for charging can be delivered, and framework for vehicle to vehicle are areas where one must work. Similarly, framework for grid support by use battery are also very important. Uh, so in short, there are softwares from NSYS and Altair. We need to buy those software and do series of simulation where we gain an edge and stand out from the crowd. Okay. I would also like to talk about this simulation technology. Like there are multidisciplinary optimization of EVs from NSYS, and one must start working towards it. So here it is, system-driven simulation for e-mobility. So there are many challenges. So there are basically various anxiety, range anxiety, charging time anxiety, vehicle integration, safety and durability, performance. All these are the anxieties which we need to solve one by one, slowly and steadily. Okay. So under simulation, we can work on design, we can work on verification, validation, we can work on manufacturing, and we can work on operation. So these are the multi-physics application for e-mobility, electromagnetic attribute of optimization, software control, vehicle engineering, electric drive, new vehicle architecture. So these are the areas. Okay. So for CAE, there are series of sub-software like we have the one for fame, and whether it is a mechanical solution or fluid solution, everything has to be done jointly. Electric vehicle modeling and simulation is one of the main area where people can work, but I would suggest to at least take a couple of months practical experience before working. So companies like NSYS and Altair conducts detailed training of their package for which are specific to electric vehicle. So electric vehicle modeling and simulation can also be done using Ricardo Wave, and these are some of the objects. Okay. EV system level simulation is also important. For example, we can conduct regenerative braking, and we can develop a battery thermal system, and so on. So am I audible?
Yes, sir.
Or
Yes, sir.
yeah. So now we are left with only 5 slides.
Okay.
So there is a provision for CAE, there is a provision for optimization, there is a provision for CFD, and there is a provision for cooling system. So all these are very important software which looks at the entire vehicle as a whole. So whether it is optimization for noise, whether it is optimization for range, all this can be optimized at CFD. So establishing the overall system specification. So we have to decide the system design specification for the entire vehicle, for the cooling system, for the detailed pack, and accordingly we need to link and work. Okay, fine. So in conclusion, I would say that electric vehicle mobility is here to stay. Its testing and certification, if it is running on Indian road, whether it is Indian or imported, is mandatory. Agencies like ARAI do a detailed testing, certification, and validation work. So one can go for testing and validation as a part of developmental test, and one can go on a full-fledged way also. So various components are required to be sourced, and its quality must be very important from the vendor's level. Uh, Finally, there would be a vehicle assembly, and uh, OEM is weak, and then the user and end of the life. EV charging infrastructure and EV use and end of life are other areas which we have recently India has started working on. So with this, I complete my presentation. Sorry for the disturbance. Couple of times it got disconnected. Uh, I would be sharing the presentation to all of you. Hope that is fine.
Okay. Okay. Dipti, you have collected the question from the student.
Yes, sir. Sir, following questions are compiled by our students as well as participants. My first question is, in electric vehicle, major cost is of its battery because they use lithium ion battery and we don't produce lithium in India. How can we cut the cost of it so electric vehicles will become more value for money mass buying product?
Sure. Very good question. Yes, there is no doubt lithium is costly and lithium is not available in most part of the India. We did find lithium in Karnataka, but it is not abundantly available. So our Niti Aayog understood this, that the cost of lithium can be a big problem, and if we are going to import lithium, there would be import duty. Up till now, we were importing lithium from China, and then later on, we started importing lithium from Japan and Korea. Recently, we have tied up with Bolivia, and our major reserves of lithium are coming from Bolivia. And so, this is one way where we have reduced the monopoly and are able to get lithium at a lower cost. The second area is that we are trying to find out alternate materials. So a lot of research is being done in ARAI, National Chemical Laboratory, ISRO, and other organizations, that what change in material can reduce the overall cost of the battery. Third area is mass production, that it's a question of economics of sale, that if you're going to produce 100 200 batteries, it will be very costly. But if you order for 1 million batteries, then the cost will drastically go down. So I am very sure with more and more penetration of electric vehicle, the cost of the battery will go down. Moreover, the most important point is the swapping of battery. So now swapping of batteries are allowed. So if you have a battery and it is fully charged, you can use it for 100, 200, or 300 kilometer, depending on range. But after that also you can just swap the battery, so that there is no loss of time and we get an efficient system. For example, in Ahmedabad, there are 100 electric buses running, and these buses have heavy battery which needs to be removed through a crane. So every day, the crane will remove the batteries would be charged, and the earlier charged battery will be swapped there. So battery swapping is another area. The fifth aspect is that government is planning that we can allow vehicle manufacturer to sell their vehicle without battery. And if this is allowed, then there will be next to the dealer, there will be a battery guy who would sell the battery and will give the battery on rent and take the entire responsibility of its charging and repair. And then it will turn out to be cheap. So
Okay.
hope that answers the question.
Yes, sir.
Yes.
Thank you, sir. My next question is, will lithium-ion battery will be dominant used battery for electric vehicles, or some other kind of battery will take its position in near future, like aluminum, etc.?
I told in one of my presentation, yeah, thank you. So as I told in one of my presentation, Dr. John Goodenough is the inventor of lithium-ion battery in USA, but he himself is now working on a new type of battery called glass battery. And if it works well, and maybe the validation results will come within 6 months, then we will use an entire different types of battery, and then this battery would become obsolete. So one has to be very careful to understand the dynamics of the situation before committing for higher costs. Hope
Okay.
that answers your question.
Yes, sir. Sir, there is one more question. Do electric vehicles also require certification every year as the gasoline vehicles?
Electric vehicles certification is happens once in 15 years. So any electric vehicle, if it is a personal vehicle, then it's once in 15 years. If it is a public vehicle like an auto rickshaw or something, or a taxi, then it is every year. So the test is required to be done every year. Correct?
Sir,
Hope that answers the
Yes, sir.
question.
yes, yes, sir. Sir, according to you, when will the charging infrastructure well built in India?
Uh, can you repeat?
Sir, according to you, when will be the charging infrastructure built in the India? Well,
Yeah,
infrastructure
so
of for
so
charging.
already, yeah, so it is being done progressively city wise. Already cities of Pune, Bangalore, Chennai, Delhi are are all fitted with battery charging system. Moreover, more and more private industries coming forward to produce battery electric vehicle. uh, Supply chain could be a big issue here, but I see that more and more people would be able to work on it.
Okay. Sir, is there any requirement of a specific cooling system like a engine vehicle in EVs?
Yes, yes. The battery and the motor needs to be cooled. We have been putting some exhaust fan or a forced draft fan in this area to cool the battery. But there are many areas by which the design optimization can help you to cool the battery.
Okay. Okay, Dheeraj sir.
Thank you so much, sir, for your valuable time and the words of knowledge and the kind of knowledge you have shared with us and with our audience. Now, I would like to request Professor Deepti Kuswaha, Assistant Professor, Department of Automobile Engineering, UIT RGPB, for vote of thanks. Ma'am.
Thank you.
Thanks a lot, sir, for answering all the questions. I hope you all enjoyed this immense learning session. It was really in grace and fruitful session. On behalf of Department of Automobile Engineering, UIT, RGPB Bhopal, and Department of Mechanical Engineering, SISTEC, R, I like to give my sincere gratitude and heartily vote of thanks to our guest speaker, Dr. K.C. Vora, sir, Chairman of HIBAHA, for this National Symposium on Recent Technological Advancements in Electric Vehicle for his wonderful, intermediate, and insightful session. I also thank our speaker, Dr. K.C. Bora sir, who despite his busy schedule and has found time to grace this National Symposium. Thank you, sir, for clearing the concepts and enhancing the understanding pertaining on the topic, what are the challenges and opportunities of electric vehicle. Today's session was full of knowledge and having interesting facts related to the electric vehicles and the battery management system. Once again, thank you, sir, for making this session is very interactive, interesting, and meaningful. I am definitely sure the precious knowledge that KC Bora sir gave our students will definitely help in the research area of electric vehicle and its future aspects. Thank you so much, sir.
Thank you, Dipti, and thank you everyone for the hearing. I take my leave here.
Sir, thank you.
Thank you, sir.
Thank you, sir. Thank you.
Thank you.
Thank you, sir.